Hi everyone, in this video we shall see the topic assignment problem. Assignment problem is one of the special cases of transportation problems. The goal of the assignment problem is to minimize the cost or time of completing a number of jobs by number of persons. Important characteristics of assignment problem is the number of sources equal to number of destinations. It is explained in the following way. First one, only one job is assigned to a person. Each person is assigned with exactly one job. Balanced assignment problem. The assignment problem is said to be balanced if the number of persons is equal to number of jobs, and it is unbalanced if they are unequal. In that case, dummy row or dummy column has to be introduced. Dummy job or person. Dummy job or person is an imaginary job or person with zero cost or time introduced in the unbalanced assignment problem to make it a balanced one. Now let us see the procedure to solve the assignment problem, that is the Hungarian method. First step is row reduction, that is subtract the minimum entry of each row from all the entries of the respective row in the cost matrix. Then column reduction. After completing the row reduction, we have to subtract the minimum entry of each column from all the entries of the respective column. Step 2 is zero assignment. Starting from the first row of the matrix received in the first step, examine the rows one by one until a row containing exactly one zero is found and assigned. Then we have to cross all the zeros in the column in which the assignment is made. This procedure should be adapted for each row assignment. That is, when the set of rows have been completely examined, an identical procedure is applied successively to columns. Starting with column 1, examine all columns until a column containing exactly one zero assignment is made. So here, by continuing this successive operation on rows and column until all zeros have been either assigned or crossed out. Here we have two possibilities. One is either all the zeros are assigned or crossed out, or at least two zeros are remained by assignment or by crossing out in each row or column. After this step, we have two situations. Assigned zeros will be either equal to n or less than n. In this step, we have to, when it is less than n, we have to move to step 3. That is, draw a minimum number of lines to cover zeros. Then, among this uncovered region, we have to find the smallest element. And the smallest element has to be subtracted from all the uncovered elements, and the same smallest element should be added to the elements at the intersection of two lines, and continue the assignment. We will get the resulting answer. Now let us see a problem and let us solve using Hungarian method. So the problem is assigning 4 jobs to 4 person. The cost matrix is given and we have to find the optimum assignment schedule. First we have to find the row reduction, that is, in each row we have to find the smallest element and subtract it to the corresponding elements of the row. Now we have obtained the row reduction. Similarly, we have to do the column reduction for the above obtained row matrix. That is, column wise we have to find the smallest element and we have to subtract that smallest element to each corresponding column. So we can obtain the column reduction. Next step is to allocate the zeros. That is, see, in first row we have only one zero. So we are going to assign that zero. In that case, once that zero is assigned, we have first element in first row. We have to check whether there are any other zeros vertically as well as horizontally. If there are zeros, we have to strike out. Here we have vertically in second row and second column we have, second row and third row we have zeros. We have to strike out those. Next, by using the Hungarian procedure, we have obtained this matrix. Here all the zeros have not been assigned in each row or column. So next procedure is we have to draw minimum number of lines to cover the zeros, and then we have to find the smallest element and subtract it to all the uncovered elements and add it to the elements in the intersection of two lines. By doing so, we have obtained this allocation, that is assignment. So we have first 0 assigned in A1 place, next 0 assigned in B2 place, next 0 in C4, similarly next 0 in D3. That is, we have the assignment schedule as A1, B2, C4 and D3. So the minimum cost is 44 plus 56 plus 48 plus 36 is 184. This is the optimum solution. Thank you.